Hello, and thanks for joining. My name's Jeff Demuth, and I'm a former AWS Solutions Architect. Now I'm a technical advisor at a managed services company in Sono, and I'm working currently on a large project in a Google Cloud environment. At AWS, I did a lot of work in geospatial, and I want to try and incorporate some of my lessons learned now from Google into the geospatial world. So previously, I just posted a video a couple weeks ago comparing some performance results between Google's AlloyDB and their CloudSQL. I've got the results here just to re-summarize, but pulling in a table, converting the geometry to GeoHash, and then writing it out, AlloyDB, both with and without the column engine enabled, was coming in at around 80 seconds. CloudSQL was almost twice as fast at 40 seconds. And for this video, I kind of want to test BigQuery and see what the performance results are for that. So with this data set, it's Overture data set. It's about 10 million rows of place data. BigQuery should do very well here because it's a column engine. Column engine databases are much faster when you have tables that are narrow, so only a handful of columns, but very deep, which is this case, so 10 million rows. AlloyDB does have a column engine, which I enabled. There's some caveats to using that. I don't think this workflow is probably a great fit for that. Also, AlloyDB is kind of built for scale, so if you had 50,000 concurrent queries, it would probably excel there. But let's see what BigQuery looks like. And so I've already run one of these. Basically, create a new table, select the old table. Now this is actually pulling off of object storage. So the performance here, because it was coming off of object storage, it's not going to be super fast, but it was actually reasonable. So it took 35 seconds. So right there with CloudSQL, even though it was reading a Parquet file off of object storage and then writing it into local BigQuery SSD drives. But let's see what happens if we go SSD to SSD. So let's change this. And we'll call this GeoHash 2. And we'll create a new table, GeoHash 2. And let's see how long this one takes to run. Yeah, so there you go. I mean, that's really impressive, actually. It ran that query in 4 seconds. So in CloudSQL even, it was still coming in at 40 seconds. You can see it read 4 gigabytes of data. Pretty good. So lastly, I want to talk about, there's on the forums, when you look up QGIS and BigQuery, there's kind of a neat plugin that you can work with BigQuery directly in QGIS. This hasn't been updated in a while, so I spent some time trying to update it. I created a fork here, and I've got it working on the latest QGIS. It's still kind of flaky. I'm going to spend some more time on it. Sometimes I have to uninstall it and reinstall it, but you can see it in action here. And I'm running my QGIS on a Google instance, a GCE instance, so I don't actually have to do any of the authentication steps here. Literally just install QGIS, install the plugin. To install that plugin, you just git clone that repo, and then zip up the files, and then you go install from zip and add the zip file here, and then you'll get this little BigQuery button. Put in your project and put in your query. We'll run the query, just a small one for demonstration, so we get 10 rows back. Select your geometry column, and then add all, add layers. And there we go. So this pulled data out of BigQuery. And I've got couple points on a map. And yeah, I mean, really good performance. So far, I mean, BigQuery has had the best performance out of all the databases. So CloudSQL, AlloyDB. And the nice thing about BigQuery too is it's completely serverless. There's no servers really to manage or log into. Like with CloudSQL and AlloyDB, there's still, you have access to Postgres under the hood, and there's Postgres things you configure. They need to be patched, even though the patching is automatic by Google. You still need to select patching windows. BigQuery is really nice. It's just you log into the GCP console and you've got your queries there, you run them, and you're good to go. So that's all I had for this video. I hope you enjoyed the video. Feel free to like, comment, subscribe. Thanks again for joining.